Question number 2. We have 3 pairs, right? Let me know which one is immiscible. So if you don't remember immiscible, please look it up. No, I'm saying I'm about to tell y'all what immiscible is. Do you need help in chemistry? Well, get ready to play your favorite game show. This game show is meant to help you, yes, you understand chemistry. Here's the game show. There's 3 questions. If you get all 3 right, we call you a brave scholar. If you get 2 right, you are a never scared student. So you kind of know yourself, or you know majority of it. If you get 1 right, well, y'all remember that show, Courage the Cowardly Dog? Well, that's you. You're kind of brave, but you're acting scary the entire time. Get to know your stuff. And if you don't get any right, well,
we have some explaining to do.
I'm your host, Dr. J, and let's play What Do You Know? Let's go to the very first question. So we have our compound here is CH3CH2OH. This is ethanol. Of these three choices, which of these 3 choices would be least soluble in ethanol? All right. And now, here's a key hint. Think about intermolecular forces, right? Think about intermolecular forces, IMF. All right, think about IMF, right? Intermolecular forces. You know the drill. Feel free to pause me, give it a go on your own. If not, let's get to it. All right, so first thing we got to remember, right, is that like will dissolve like. So let me see what type of intermolecular forces I see here. In this case, we're definitely going to see some hydrogen bonding taking place here, right? With basically, you remember hydrogen bonding, if you have a hydrogen bound to a nitrogen, oxygen, or fluorine, you have hydrogen bonding taking place here. So basically, right, like dissolves like. Let's look at our potential, right, answers here. H2O, I know that's a hydrogen bond. All right, I know we got hydrogen bonding with the hydrogen to the oxygen. So it's very possible and most likely, yes, water can be dissolved in ethanol. Ethanol can be dissolved in water. Okay, very similar substances here. So I'm pretty sure it's not going to be A. What about B? All right, so B, CH3CH3, this is a nonpolar, basically, substance here, right? And I can see here, right, what type of intermolecular force is it going to have? And this is a 3, y'all. That's a 3. That did not look like a 3, but that's a 3. Okay, so CH3CH3. What are we thinking here? Well, we're going to have dispersion forces. That's the force that we're definitely going to see. Do we see any other type of intermolecular force? No, right? It's not going to be any dipole-dipole or ion-dipoles, right? Because this is not a polar molecule. So it can't be those. And then I don't see any hydrogen bound, right, to nitrogen, oxygen, or fluorine, right? Based on if we were supposed to draw this thing out, which I could do very quickly here. Basically, I can see, right, hydrogen, 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 right? I don't see anything bound to nitrogen, oxygen, or fluorine. All right, so I'm confident, right? I'm pretty confident that it might be B. Let's go to C. CH3OH, right? Well, I see a OH here. Automatically, I'm thinking in my head, hydrogen bonding. So if this is hydrogen bonding and that's a hydrogen bond, well, these are going to be very similar, so they can probably be dissolved in each other. So if you guess B, you are correct. You are correct. All right. Once again, like dissolves like. In this case, dispersion bonds not going to be able to be dissolved into this polar molecule. All right. So this is not nonpolar. This is a polar molecule. Question number 2. We have 3 pairs, right? Let me know which one is immiscible. So if you don't remember immiscible, please look it up. No, I'm saying I'm about to tell y'all what immiscible is. Okay, so immiscible basically means that they're not able to be dissolved with each other. Okay, so miscible, right? We understand that they could dissolve each other. Immiscible, they're not able to be dissolved. So which one of these 3 do you think is immiscible? You know the drill. Feel free to pause me. If not, Let's get to it. First one, carbon tetrachloride. Carbon tetrachloride is going to be, all right, so this is a non-polar compound, right, with that CCl4. This is non-polar. And then hexane, right, just looking at that, we know that this is a 6-carbon chain. It's going to be also a non-polar compound. So if you remember, right, like dissolves like, check that video. We're going to know that these are going to be able to be miscible with each other. So I don't think it's going to be this one right here. What about water and ethanol? Water, I know, is a polar molecule. Ethanol, with the OH group here, is going to be a polar molecule. And polar molecules like to dissolve each other, so like dissolves like. I don't think it's going to be two either. So water and ethanol are miscible with each other. What about 3? We got water. We just explained that water is a polar molecule. Carbon tetrachloride. We just explained that this is a nonpolar molecule. So polar and nonpolar molecules do not like to dissolve within each other. Okay, these two are actually immiscible. And if you guess the last one, number 3, you are on a roll. Okay, if not, it's okay. We still got one more to go. All right, so your last and final question. Which of the following ions will contribute most to elevating the boiling point of water? Okay, so we have a sodium ion, we have calcium ion, and then we have one other answer, which is both. You know the routine. Feel free to pause me, pick your answer. Let's get to it. All right, so boiling point, elevating. Okay, so boiling point elevation. Does that ring a bell in somebody's head? Yes. So if you remember about boiling point elevation is a colligative property. Now, who remembers what a colligative property is, right? Colligative properties, right, is basically where you don't care about the identity, right? I don't care about your identity in this case, right? It matters as far as how much I put in, right? How much of that substance I have. So, right, which of the following ions will contribute most to elevating the boiling point of water? It doesn't matter if it's sodium or calcium. It's about the amount that we put in. And since there is no specific amount stated here, it's actually both. So, they can both contribute to elevating the boiling point of water. All right? Trick question here. So you got the one right. Shout out to you. Shout out to you because you understand colligative properties. If not, it's okay. There is okay. So how did y'all do? Did you get 1 right? Did you get 2 right? Did you get 3 right? Or did you not get anything right? Okay, let me know in the comments. Thank you for playing What Do You Know? What do you know? What do you know?